In his research, Peter Nilsson is building molecules that send out a light when they attach to proteins with faulty structure that tend to lump together in the brain as clusters, as in the case of Alzheimer's and several other aggressive diseases.
The molecules that I was working with was normally actually used for light-emitting diodes and solar cells. But by chance I teamed up with Per Hammarström at Linköping University, and he is an expert on looking at protein aggregates, the things that are associated with the types of diseases like Alzheimer's disease and the prion diseases. And when we tried the molecules towards these aggregates, we actually saw that we were able to detect these aggregates with the molecules that I was working with. This discovery led me to switch research areas and moving to Zurich and to a research group that are world-leading in diseases like Alzheimer's disease, type 2 diabetes and the mad cow disease.
The research in Zurich led to an international breakthrough, and the molecules that Peter Nilsson and his research team built to detect the diseases are now used in laboratories around the world.
At the moment, the molecules that we're using, we are able to see these things in the test tube and also then on tissue samples when we're looking in a microscope. But hopefully we will be able to modify the molecules so we can also use them for other techniques that we normally today using for clinical diagnostics of these diseases.
Currently, there are no effective treatments to prevent Alzheimer's disease from progressing. One of the reasons for this is that so far there haven't been any good methods for detecting the disease at an early stage, so the impact of Peter Nilsson's research could be immense.
Of course, the aim from a scientific perspective is that we would like to know more about the diseases, so we can actually then find novel things where you can develop some kind of pharmaceutical that helps preventing the disease. And from another aspect, we also then would like to have this clinical test for the disease, so you've been able then to make early diagnostics of these types of diseases.
At the moment, the aim is to modify the molecule so that the signals can be detected with a magnetic camera and nuclear medicine imaging techniques.
However, we should be aware of that if you're going to use these things for clinical diagnostics and also then as a pharmaceutical, then further testing needs to be done also, since you're going to put these things in human beings.
Peter Nilsson and his research team are constantly searching for new application areas for their methods. Currently, they are designing molecules that attach to cancerous cells. The goal is early diagnosis and development of new treatments.
For me, who's doing this kind of multidisciplinary science, when we're actually creating molecules in the organic chemistry lab, and then we're actually aiming at using these molecules within the field of medicine, of course cooperation is essential, since we need to have different kind of expertise. We need to have people that know how to build the molecules, but we also need people that understand the pathology of disease and so on.